Okay, so in this video, folks, we're going to be looking at integration by substitution part 2, which means we're going to look at it with limits. Okay, so just a wee note to start us off. You must be very careful when calculating definite integrals. That just means integrals with limits. Using substitution as the limits of integration change. Okay, so that's just a wee note. And if you think about why we use substitution, we're changing the question using a different variable, which means that if they had limits in the original variable, the chances are those limits will change when we want to substitute something else into it. Okay, I'm just going to show you a couple of examples to show you how this would work. So, example 1, we're going to have an integral with limits 1 to 0 of 15x squared bracket x cubed plus 1 to the power 4 with respect to x. Okay, and the substitution we've been told is we're going to let u equal x cubed plus 1. Okay, so that's what we've been told to do there. So the first step that we're going to do remains the same, as in we need to differentiate that u function. Okay, so we're going to have du by dx, which becomes 3x squared. And if you remember from the previous video, we want to substitute dx out, so that means we're going to rearrange for dx, which means that's going to be du over 3x squared. So nothing's really changed yet so far. Once you've done that, this is when you now deal with your limits, okay? So we need to get our new limits. So if you look at the question, the limits that we've got is for x, yeah? They'd be the limits that you substitute in for x once you've done your integration, okay? But we want to substitute that out for u's, so we want to get the limits for u, okay? So when x equals 1, that's our first limit, okay? Then u is going to equal, so we're going to substitute that into our u function, okay? We're going to substitute what x is into the u function to get what u would be. So that would be 1 cubed plus 1, which becomes 2. Okay, so our first limit is going to be 2 for u. And then same, when x equals 0, that's our second limit. Then u is going to equal 0 cubed plus 1. Therefore u equals 1. So our new limits are going to be 2 and 1. Okay, that will save us changing the function back out at the end. Okay, we can just use those limits for u. So let's substitute that into our equation. So the integral between 1 and 0 of 15x squared x cubed plus 1 to the power 4 dx. Well, that's going to become, well, the integral between 2 and 1. So I'm changing my limits for u. Okay, I'm going to have 15x squared bracket, well, x cubed plus 1 was u, so that's going to be u to the power 4. Dx, well, that's going to become du divided by 3x squared. Okay, so I've just substituted my limits in, my new limits, and I've substituted what u was, and also what dx was as well. So the x squared is going to cancel. 15 divided by 3, that's also going to give me 5, so that's going to equal 5u to the power 4 du with limits 2 and 1. Okay, so the x squared is cancelled, 15 divided by 3 would just leave me with 5 there. Okay, so if I do the integration now, so that's going to become 5u the power of 5 all divided by 5. Let's limits 2 to 1. Always tidy up before you put the limits in, so that's going to be u to the power of 5. Limits 2 to 1, so that's going to be 2 to the power of 5 minus 1 to the power of 5. That becomes 32 take away 1, which becomes 31. Okay, so therefore we didn't have to substitute our old function back in because we got our limits for u instead, and we could just do it with that. You okay with that first example, yeah? Excellent. Okay, we'll look at a second example. So example number 2, we're going to integrate the limits pi over 6 and 0 of 10 sine to the power of 4x cos x dx. And here we're going to let u equal sine x. Okay, so again, first step is we're just going to differentiate u. So du by dx was going to give me cos x. Therefore, for each for dx, I'm going to get du divided by cos x. Okay, right, we also need to get our new limits. So when x equals pi over 6, u is going to be sine of pi over 6. Pi over 6 is 30, so sine of 30 is the value of half. Okay, you get that from your exact value triangles from higher there. And when x equals 0, u is going to be sine of 0. And sine of 0 is just 0. Okay, so sometimes your limits might not always change. Okay, one of them has, but that last one did still say the same for that function. Okay, so let's pop that in to our question. So the integral between pi over 6 and 0 of 10 sine to the power of 4x cos x dx. Well, that's going to be the integral between half and 0 now. That's what those two limits became, half and 0. 10. Okay, so u was sine, so that's going to be u to the power of 4 cos x times by du over cos x. So that's what dx was. And again, thankfully, cos x's will cancel. So therefore, I'm going to get the integral between a half and 0 of 10u to the power of 4 du. Okay, so we get down to that stage there. Let's now integrate this. Okay, so we know how integration works now. Add on to the power divided by a new power. That's going to give me 2u to the power of 5 between the limits half and 0. So that's going to be, in fact, we'll write this underneath. 2 lots of a half to the power of 5 minus 2 lots 0 to the power of 5. So that becomes 2 lots of 1 over 32 minus 0, which becomes 1 over 60. We okay with that?